All right. Yeah. Thanks for joining. Yeah. So this is another thank God it's KubeNet session. So this time we have Marcus, who is one of the key developers of SDC, who is going to go into more depth on what it is about and get you some clarifications on what it does and with some demos and stuff like that. So, Marcus, take it away.
Yep, thank you, Wim. So I think in the in recent sessions, you've seen what what the KubeNet components of the upper layer are all about, right? So you've shown a lot of the choreo component and so on to transform a high level abstraction into more and more precise device configurations down to a configuration that can be applied to a device, right? So these steps were all about transforming from high level to more specific. And now the question is how to push these configurations out to the device. And that's especially the gap that SDC fills. So SDC, just the abbreviation for schema-driven configuration. So we heavily rely on a schema since we need to do a lot of data transformations. So from Kubernetes, we get obviously Yang data, Yang configuration, and the devices will be configured with XML, for instance, or Proto or JSON. So all these formats need to be converted into one another. So in general, SDC does bridge the gap between Kubernetes and your NOS in the end, providing this declarative configuration management. And while doing so, we will also, like as part of the Yang schema, you will get a lot of constraints in that Yang schema that tells you what data should look like and how it is it's made up. So we will also be able to perform all these validations of box within SDC, and only if all of that stuff is valid, really bother the box with a new snippet of configuration. SDC itself, as said, relies on Yang and protocols like gnmi and netconf, which makes us vendor agnostic. So every vendor, every platform that provides these interfaces plus the schema will be able to configure and integrate into the Kubernetes ecosystem or the KubeNet ecosystem. SDC itself comes with a couple of components, as you can see here. Like at the top here, we have the config server. The config server is a so-called extension API server. What that means is that it is basically the same like a regular Kubernetes API server, but it's not standalone. It integrates into the main Kubernetes API server, registers its own CRDs in there, and the main API server basically proxies the resources and sends them towards config server. Config server itself then also contains the reconcilers, the controllers for the specific CRDs that we will see a little later. That's the top part here, and then further down we have in the center the data server. The data server is the component that talks to the network devices, the NOSes, the virtual or physical containerized network functions via, as I said, gnmi or netconf. RESTconf would also be an option, but yeah, we haven't focused on that so far. The data server takes in all the configuration intents that either the user inputs or are coming from Git or that Choreo buildup, takes them in as intents, loads running configuration from the device, and calculates the transformation that needs to be done to the configuration. To the left, we have the schema server. So the schema server is a separate component. It holds the Yang schema and also makes it available via gRPC, such that the data server can access all the schema components in schema server and validate and transform all the configuration that's either coming from the top, going to the bottom, or also coming from the bottom up into data server, because also there we need a common representation of all the configurations. And then to the right, we have the cache server that is a state store, stores running configuration as well as intended configurations for the data server. By the way, if you have any questions, just feel free to ask them straight away.
I think one thing to clarify, I think at the moment, is that our packaging today is using a pod, right? So we put them all into a single pod. The architecture is built to build it in a more scalable and distributed way, right? So each of these blobs that you see here could become eventually a single, their own pod, right? Each of the circles could be an independent pod that scales out. Now, we haven't tested that completely, right? But so it's architected to be able to scale out in that fashion.
Right now, it's actually two pods, right? So the config server is its own pod, and then we have data server, where the data server binary.
It's
the data server
it's a
binary
single with two containers, I think, in the same pod. Yeah, that's what it is today.
You're right. I'm sorry. Yeah, two containers, single pod. Yep.
Hi guys, it's Dan here.
Yeah. Hey Dan.
Hi.
Yeah. Thanks for joining.
It's been a while since I looked at SDC, but I seem to remember last time there was mention of a package server. Is that still there, or is it named something else?
So the package server is it's also a component that we developed in KubeNet. It's mainly to be compatible with Nefio, right? So there is still the idea to use Nefio, right? And basically, so because Nefio has a specific way to get these configurations, right? So the package server is actually a component inside of KubeNet to do that, but it's not in this context, if you use Choreo, for example, you don't need a package server because you have a full Git server there, right? But Nefio uses specific packages with KPT and stuff like that. So the package server was a component that we built originally to be compatible in Nefio. But yeah, if you don't use Nefio, you don't need that.
Oh, okay, right, that's clear. Thanks.
Okay. So yeah, this is an overview of the CRDs that come along with SDC. Here, all in the center, you see the target. The target is the entity that defines your device, your NOS. It is a reconciler created CR. So you as a user would not create the target straight away. You would go via the indirection of a discovery rule. Discovery rule takes in either a static IPs or an IP range, along with the other CRs or resources you see here to the right, to compose, like to scan the network or create due to the static IP these targets. A discovery rule will reference secret for authentication against the target. The young schema as a separate CRD definition, a connection profile and a sync profile. We've decoupled these because what it allows you in this way is to have a connection profile, which is the profile that's used to deploy configuration, to push configuration to the device, to use, for instance, netconf there, but doing the sync-in via gnmi, telemetry streaming or such. So that's why these are separated. And you see we have active reconciliation only for the schema, for the discovery rule, the target, config, and config set, which means you define a schema, and the schema has to be retrieved and made available, registered in the schema server for the data server to access it. That's why we need to reconcile this. Discovery rule obviously then needs to create the targets based on the static IPs or the discovered endpoints within a network range, or the other two options are services and pods in Kubernetes that we can discover and create targets upon. The two other reconciler created CRs are the unmanaged config and running config. That's basically unmanaged config tells you about configuration entries that you did not configure via intents, but are there, right? So it tells you unhandled configuration, like brownfield configuration. Running config is a representation of the configuration that we retrieve from the device. So we also make that available in the Kubernetes API server. And then down at the bottom, we have the config, which would be a single intent for a single device, referencing a single target by name and telling like this config snippet should be applied to device to target XYZ. or a config set, which actually references targets by a label selector, which means, do you have a question or can you unmute? Perfect. Config set, which selects targets by a label selector, which means it can match to multiple targets. And what it will do as a result of that, it'll create configs per these targets, such that you can apply a common template, a common snippet to the targets that match the label selector. Yeah, I've already talked about it. Schema controller is there to download the schemas and make them available for the data server to use in transformation and validation. Discovery controller to discover targets and create them in the Kubernetes API. The target controller to manage the life cycle of that target, and the config controller to manage the life cycle of these configuration snippets, reapply them to the data server such that they appear on the box. Yeah, this I've already talked about in the overall view, right? So we have the secret, the schema, and the connection profiles that are used to, in conjunction with the discovery rule, to create the target that references all of these to be able to access access the box and retrieve configuration, push configuration, and be able to do the validation and transformation. What does the schema, for instance, look like? How do you define it? This is a view. So we've specifically in the Arista environment, we figured that we needed multiple repositories. So we're sourcing the Yang models out of Git. So we've seen that, like, basically all the vendors provide their Yang models in public Git repositories. So on GitHub. So we said, okay, we base the whole thing on GitHub repositories where we pull the Yang schemas, so no one has to download them manually and push them there and blah blah blah. It's just come up with the reference to the repo and define it like this, and it'll be downloaded. So yeah, basically what it does is point to the repo. Then we've seen that there's multiple ways that vendors manage these repos, right? Like some use tags, others use branches per version, and even others throw everything into the main branch and have just folders per version. So yeah, we needed to provide the flexibility to reference to those, right? So either tag or branch, and then yeah, main or specific version or whatever. And then for the schema to load, what you need is the main model. So the schema usually has a main model, and then includes, right? So in this case, you see here IETF and OpenConfig. Like from IETF, usually I think the definition of an IP address is being sourced, right? So they have defined a type IP address with a regex pattern, what an IP address looks like, and the SRL model in this case simply sourcing that and using it within the broader model. So yeah, you need to have the reference to the main model, to all the includes, and in this case we also have excludes. We have some some tools, Yang models, that we do not use within the scope of SDC. So we had to exclude those. And this is basically loading the schema then. What we figured, since Yang is quite complex, quite a complex matter, that a lot of Yang models are like broken and do not compile in any case. So in this case, for SL Linux, we have deviations, so you can deviate from the main models, from the main schema, and alter them to make them fit. So we had to do this in a couple of places. We also have this for 2 or 3. We've done that work also for 2 or 3 Arista versions and so on. So that's basically why we had to come up with multiple repositories that we then add together into a single repository, schema repository. So
I think maybe one thing to add, Marcus, also what we saw is that some vendors do not, they only have in their repo only the main modules, right? But then all the imports like IETF comes in another repo. So we had to do some work. I think then you reached, you hit that issue in the beginning, right? So we now rework the schema such that you can leverage, so you can basically reference multiple repos as you saw before, right? So each of these repositories is an entry, is a list, so you can actually reference multiple of these. And so, for example, I think in the Arista example, we have 3 of these, right? So that some case you only need 1, but we have the ability to compose a schema from multiple repos or, so that's basically what we did to accommodate for various implementations or the way that they expose it. Also, Sonic, for example, has the same issue, right? So you need 2 of these to make Sonic work, for example.
I think Dan, it was you, right, who came up with the 2 schemas, then somehow mangled together, right?
Yeah, I did a bit of testing with Arista, and I found this issue.
The previous approach, the challenge that we had with what you did then, right, was that depending on the order that we put them in, it either worked or not. So we had to rework the way that we did it. So that's why we merged it all in one schema, right? And that you have multiple repositories, because what we saw when you had multiple schemas that point to the same provider, we had the issue that depending on the order in which they were resolved, it either worked or did not. So that's why we reworked the schema to have that list all in one CR to be able to accommodate and avoid that issue.
Yeah, that makes sense. I have a quick question actually about the management and pushing of the config. So it seems like you're working more on the basis that this is done as like config snippets, and where you have config being pushed by SDC, that then becomes managed, and then that part of the config, you wouldn't have the unmanaged part of that config in SDC, because that would be basically managed. Is there an option to basically do a full replace of the whole config and therefore have everything managed? Because the problem I see, at least with us in a brownfield deployment, is that we currently have one way of doing some kind of automation, that we push full configs to the devices. And if we move to something like SDC, we kind of have to do a little bit of a big bang migration. Otherwise, we have 2 tools running at the same time, and we introduce drift into the other one. So at least in my scenario, I kind of see it more that it makes sense that we do, kind of more of a big bang approach. We get everything working via SDC, we get the full config represented via SDC, and we say, right, we switch from one to the other, and we do a full config replace via SDC, and everything suddenly becomes managed by that tool. Yeah.
I think you can do that today then, because if you would put at the config snippet the full configuration, right?
Yeah.
So we do that now. We also have been discussing, so today, what the data server does is we calculate the diff, right? So in other words, we look at running, right? And then we look at the new, let's say if it's a full config, we look at a full config, and we are calculating the deltas, right? And what we transact to the device is a delta. And then we retrieve the config back, right? And then we represent it. Now,
Okay.
So now we have, so that's how it works at the moment, right, Marcus, right? So we basically do the delta configuration. We have actually discussed, was it this week or last week, Marcus, a way to also give you an option to do a slash replace. So in other words, instead of doing the delta configurations, we do just replace, right, operation that you say, okay, this is now relevant, which we anyhow need for rollbacks and stuff like that, right? And we just need to see how we would expose something like that, right? But long story short, so I think being able to give the full configuration that you calculate, you can do that today by just supplying the full configuration into the config snippet. Right?
Yeah. You just take the running config and apply it as a
new
intent.
Or a new version of the running config that you want to apply. And so we can do that today. The only thing that I was trying to clarify is the way that we do that today is we would calculate the delta against the running config that we have, and we would apply that delta to the device rather than doing it with a slash replace operation. You see?
Yeah, but I think it should, in theory, that works anyway, I guess, right? Because assuming that the config is exactly the same and there's no delta, then it's pretty much the same thing, I guess, right? Or it sounds like
result in the same.
You could even leave the existing configuration like untouched, and like over time like look into unmanaged configuration, see like which paths are not managed, are unhandled, reported as unhandled then, and like introduce the intents gradually and like convert them to managed configuration then over time, right?
Yeah, I think
because taking it as a big bulk and just shoveling it in is also kind of bad practice, right? You would want to have it probably like ordered or organized by services or whatever, right?
Yeah, it's tricky, I think, and it probably depends on your scenario, because if you don't have any automation and you're introducing this, then yeah, I think it makes sense to do it like that, bit by bit. The way you're moving from one tool to another, and you basically have to cut over from one to another, it's trickier to do it like that, I think, because you introduce drift into the other tool, because you have two tools acting on the same device. So yeah, I think it can work both ways, though. I mean, by the sounds of it.
We designed it always to have both ways, right? So we were more focused on the config snippets, and the reason is that we were on this full intent role, or let's say discussion. There you need this merging and config snippets and stuff like that. But we also, so you have the ability to do the full config right now. Yeah. So we always try to do both, right? But we have been doing a little bit more development on this config snippet because it's more complex, to be honest. Because the running config is like, if you take the whole config, it's like one operation all the time, right? But I do see a need. We see a need for both of these things.
Yeah, that makes sense. Yeah, thanks.
Sorry. Yeah.
No worries. We're here to have these discussions, right?
About the YAM models, if possible. Do you have what will be happen if the downloaded or defined schemas for YAM models will be having the same XPath if that does have some prioritization, or is it just listing? We have to understand that it have to be not overlapping Yang model have to be used.
Yes, we've encountered these issues. What we did for now was to, for instance, IETF would also have slash interfaces defined, right? So that would shadow the cover the actual models defined slash interfaces path in certain cases. So what we do is we have defined a list of common known models that we deprioritized, right? So it is IETF or IANA or I think OpenConfig. I'm not sure. We've added that list, and when looking up the models, they would be deprioritized, and you would rather get ones that do not match these names. We will have to still provide the ability to you as a user to define this list and maybe like more granular priorities. But yeah, for now we've done a bit there.
Okay, clear. Thank you.
Right. So yeah, as we said, we rely a lot on Yang schemas that define the structure, the schema of the data. What you have in Yang is the base building blocks of modules, containers that define relationship between nodes, lists of identical entities in there. Then as the final level, you have leaves where the actual configuration value is defined on, and also things like types and so on, like is it a string, a uint, an int, whatever, and further a lot of constraints that are defined within the Yang schema. This is just a very short snippet where like a lot of the module definition and so on is missing, but just to give the guys of you that haven't seen Yang schemas a bit of a sense of what's going on there. You see here a container network that contains a list called interface. Elements in that list have a key, so they're identified by the attribute name. There's descriptions in it telling you like what it's all about. The types, as said, in this case, the name is a string and must follow this specific pattern. And then over here, enumerations, and yeah, then even more trickier, you have must statements, which are basically XPath statements that can reference any other node within the configuration tree, and yeah, add constraints to those for this entry to be valid, right? If that's not valid, you will get an error. Speed must be at least 10 megabits in this case, and yeah, that can be all sorts of relations between nodes and all sorts of checks. So yeah, that's basically how rich such a Yang schema is. We're trying to pass like the whole schema and validate all of the possible all of the possible constraints that are defined in here.
Submodules also supported.
Yes. Right.
So I think from a Yang perspective, yeah, we are using GoYang, right? So there are some, I think whether we are 100% compliant, I think in the meantime, we have lots, we have done quite a bit of testing. We have to do some more, but our goal is to be compliant to the Yang specification, but we have to do some, let's say, workarounds because GoYang is 1.0 mainly compliant, is not 100% 1.1 compliant. So we are working with the open config people. We have reached out to them to see what to do and how we can accommodate for that. But at the moment, we are doing some, let's say, tricks, if you will, to enhance the GoYang environment to support the 1.1 definitions.
Very good.
Yeah. So, for instance, one of the issues you have is the pattern. So pattern here, as you see, in 1.1, they've introduced an inverted match flag, right? So you can add an inverted match down here, I think equals true or whatever. So that will invert this pattern. But yeah, that's not part of 1.1. And if you take a look at GoYang, the pattern is like in the structure, they internally keep the pattern in. It's just a single string, right? So there's no way to like signal now that there's also an inverted version of this pattern or whatever. So introducing that would be a breaking change and whatnot, right? So yeah, we will need to discuss with them how to get that in. Yeah, not that easy.
Yeah, we have some PRs open on that.
That's PRs at least that do still fit in the actual model that are not breaking changes, right? But yeah, for the breaking changes, we've tried to at least start discussions, but yeah, I have to see how they will turn out in the end. Yeah, so on the validation side, what we do validate so far is leaf refs. So leaf refs say if you define your interface Ethernet 1 under OSPF as an interface, right? That will most likely be a leaf ref that where the OSPF leaf value points into the interfaces, and if this leaf ref is not satisfied, like the other end of the reference leaf is not there, that configuration is basically invalid. Ranges, yeah, it's pretty self-explanatory. Ints or numbers have to lay within a certain range. The length of some strings that should not exceed a length. Must statements, as said, the relatively complex XPath expressions. Mandatory flags. So, for instance, under BGP, you can't operate BGP without setting the local AS. So that usually will be a mandatory attribute. So if you do not provide it, we will also it's not there. We will also complain without even sending that stuff to the box. Patterns, as we've seen, regex patterns, and then we also have choices. So choices on the box are pretty easy to implement. You can, let's say, you can either have OSPF or ISIS, right? So these are the two cases. and on a box, if you have ISIS configured and now you start configuring OSPF, it'll vanish, and like only one can be active. In our case, we have all these intents with priorities and so on, and we need to keep track of all of these and see like with what case has the overall highest precedence, and only then apply that case over the other. But yeah, we will also do that sort of validation. Yeah, I said connection profile is there to connect to the device to push configuration. In this case, you again see an example here. You define the port, the protocol, the encoding that you want, and then yeah, skip verify, insecure, depends on certificate and trust settings. The sync profile is a little contains a little more knobs. Should the sync data from the device be validated? Should we like do all the validations on top of that, although it's coming from the device? And then what paths to sync? In this case, again with gnmi. And we define the paths, so you can also go and only subscribe for a certain path or a certain path with enhanced within tighter interval, and maybe different encodings or whatever. So that's the target sync profile. I said all of these need to then be combined into the discovery rule. In this case, you see a discovery rule with a static address. So that's this part here. So the address, so this address with this host name should be. Do we do probing for static IPs then?
Yeah, for the schema, right? We do, yeah, because even in the so I mean, there is actually two things that are happening here during discovery. One is figuring out what the IP address is and whether we can connect to it, and the second is to define what version and schema is used by that target. So these are the two activities that are happening during discovery, right? And so you can actually the true discovery is actually around figuring out the schema. That's actually what discovery is. But of course, in order to do so, you need to find the IP address, and you can. So we basically try to, so in that whole process, so there is two things. One is finding the IP, and you get the IP address via so either you can define it statically, like you see here. We have the ability to say because sometimes people deploy it inside of a Kubernetes cluster, so through a pod or a service, figure out the IP or DNS record for that matter. And so basically the address can also be a DNS name, by the way. It doesn't have to be an IP address. And then we need to figure out the schema that is used by the target. And so that's when true discovery is coming into play. But you can also manually or statically define the provider that you use, in which case no discovery is happening. That's kind of the process here. So there's a few. So there's basically two things happening. One is to find the IP, if you will, and the second is to define the version that device is about, because we need to refer to the proper schema to do the validation.
Can we subscribe to changes?
Yes, so we are. Yeah, so basically, what happens is, so for example, if you would do a software upgrade, right, to a device, right? So let's say someone does a software upgrade. That's why this periodic time is there, right? So we rescan every X amount of time to figure out what is going on, right? So we actually, so that's why this period of 1 minute is there to rescan and figure out if something changed and stuff like that.
But I mean, can we subscribe, for example, for the config XPath for config tree to have the device push to change config changes to the target by themselves,
yes,
not pulling.
So what we do in the target sync profile, right? We sync. So are you asking about a change in the configuration, Evgeny?
Yeah.
Yeah, correct.
If something changes, device pushes the data to the SDC, not SDC pulling the device.
Yeah, so there is an option here. But we see that not all vendors support it. So we can also do a sync profile with mode on change, right? So in other words, in that mode, we will get a notification, like for state, to actually get information about the change of the configuration. So, but what we have seen is that not all vendors support that mode. In other words, in that case, we don't have to pull, but we get a notification with the changes. So we have a mode which is, instead of get that you see here, we have a mode that is on change, in which case we get notifications.
Okay, thanks, Ian.
Yeah.
Okay, so yeah, that's the discovery rule that then, as a result, creates targets, and yeah, this is an output of a discovered SRL device, right? So you see the name of the device def1, it's ready, so all the state and so on in the background in the data server and so on is provisioned. The provider and yeah, the address and like some discovered data from the device that was picked up while doing discovery.
Yeah. And this here we may have to do some pluggability here, because at the moment we implemented Nokia, but we should. One of the things that we need to do is make it pluggable, such that we can basically do a small plugin to see what is the serial number in Cisco or in Arista or other vendors, and then just fetch them. So it's a small thing that we have to add here to make that more flexible.
Yeah. Right. Then the CRDs that we're all looking for, right? Config CRD is the one that contains the intent, the configuration snippet. It has a name. It labels, defines where to like which device it belongs to, right? The target name. Every snippet has a priority. So if there's another snippet that also defines the description of System 0 interface, then the one with the highest priority will win and will be pushed to the device.
Yeah, just to clarify this, you can also do, like we discussed before, I think, Marcus, the full config, right? So it doesn't have to be the snip. In this case, the config is the full config. Yeah.
The full config is also a snippet. You just define it as being complete, right? So,
yes, correct. Yeah. That's what I was trying to clarify. Yeah. The snippet can be also the full config.
You don't have to add it from or define it from the root on, right? So you can define a relative path, and then everything that comes under value is the configuration that sits under this path. In this case, it sets up at root, and then these are the values to be pushed. How do these intents in general operate? So configuration values are added. So we build up a tree with these intent values and also merge in running later on. So we have a whole tree of that configuration. Every bit of configuration, every configuration value that comes in is taken into that tree as a single instance, right? So there's no all or nothing on these intents. They are all merged, and all of the specific values are merged based on priority. So we take them all in, figure out the highest priority per leaf, and these ones will define the expected, the intended state. And then on these, I said, merge in the running, and then we do the validation with all the validations that we've talked about. And if these validations do not yield any errors, any issues, we will then go and push it to the device. The protocols and encodings that we've implemented, JSON, plain JSON, JSON IETF is basically the same as JSON, but all the containers and leaves and so on will be prefixed with the module name. Also, if you have identity refs or whatever, these will all be prefixed with the module or proto, the relatively lightweight binary encoding, or in case of netconf, it's obviously XML. And then, as said initially, the config set, which is a template-ish kind of configuration that applies to a set of targets, where the set of targets is defined via the match labels. You see here we're targeting the label SDC def region US East, and if we scroll up a lot, discovery rule, yes, here in the discovery rule, we've defined that for everything that matches this discovery rule, a target would be created, and the template for this target also has a label defined, and all these labels that you define here will be applied to the target. So we're targeting these labels now, and what will happen is that the config set controller will create configurations per matched device, and these will then be picked up by the regular config controller and pushed to the target. Yeah, so unmanaged configuration, just to see what they look like. You will get a status. The status field is being filled out. There's no spec for it, and then you see for all the paths within the configuration, in this case the desired value is nil, right? So there is no intent that defines this this configuration field, and that's why the reason is unhandled, and you will get all of the brown field data that is defined on the device but not defined in any intent. You will see that in this list. And then we have the running configuration. That's the view on the running configuration in the Kubernetes API in YAML format. You will see that, or JSON, depending on the output format you request, and you will get the running configuration. And that's the slideware. So I think we only have 2 minutes left, right?
Yeah. The question is, what do we do? We have prepared some demos, I think, right?
Yeah. So I'd be fine to just continue, and I mean, we would need a new meeting, right?
Yeah, either we continue or we do a follow-up. I don't know what you guys prefer. We do it for you, so it's like.
For me, I kind of need to leave in about 5 minutes. I'm still in the office, so yeah, I would prefer a follow-up if it's possible. Yeah.
Okay,
Sure.
that's fine. And we'll schedule next week, maybe. Yeah, if that works on Thursday.
Yeah, that would be great. Yeah. I
Yeah.
just had a quick question actually about the unmanaged config. So, let's say that you have a device and all of the config is managed there. You don't have any unmanaged config, but someone goes to change something on the device. So I take it by default, it would just be flagged up as unmanaged config, and it wouldn't be overwritten. But do you think
right now, our standard mode of operation is to revert. So we would change this deviation. So for unmanaged right now, you would only see unhandled, because everything else, we have this sync timer that triggers the sync from the device, right? Because we're focused now, as Wim said earlier, on gets, not on change notifications. And then we would take in the configuration and we would trigger to reset that value to the intended one.
Yeah. Okay.
Now, so just then, so there is, I think there is two. So I want to clarify one more thing, Marcus. I think if you would set a configuration path that we were not configuring, it would be seen as unmanaged. So there is, so in other words, we call this deviations, right? As you saw. So what we have is like we get a new configuration from the device, and we handle that as deviations. And so there is 3 types of deviations, if you will, in how it is being handled under the cover. One is, okay, we don't have a path for it, or we don't have a value, so it's coming back as unhandled, and that is put in the unmanaged config. And then you have 2 other types of, we have a config, but it was overruled by another intent, in which case we just report it as, hey, there is a deviation, but it's an intended deviation, because you basically had 2 config snippets and they were conflicting. Yeah. So we just don't do anything for that. And then the third one, which is the one that Marcus was explaining, is basically there is a deviation from the intent, and at the moment we automatically revert. We can build a knob to basically not do that and just add it into the status and report it. But at the moment we don't have this knob.
Yeah. No, that's why I was wondering. I was thinking of the case where you might need to troubleshoot something really quickly and change the config, and you then want to turn off basically overwriting the config, right?
Yeah. So in that case, so we know that we have to add that knob. It's pretty easy to do, actually.
Yeah. Okay. Yeah, makes sense.
Now, I think maybe in the sake of time, because we'll do a follow-up. So we are working on a transaction interface, because what we have seen right now, so what we do right now is we get a config and we apply, right? But you have not really a way to revert if something failed, or if it works. If it's not successful on this device, nothing will change. So that's okay. But sometimes it might be that if you do a network-wide implementation, that it worked on one device but did not work on another, and you want to basically revert, right? So we are discussing, and maybe we can go into some details in the next session when we do the follow-up on a design to accommodate for that. So we can share what we are doing there, such that you have also that we have the capability to do what we call a network-wide transaction, but you can actually do that also on a per, let's say, device basis.
So it's kind of like an atomic transaction, right? Either it all works, or if something fails, you roll back everything.
Yeah. So the idea, is typically
spanning multiple devices.
Yeah.
That's what it is right now already. So if that single intent doesn't blend in, doesn't work, then nothing's transacted. But yeah.
I will share with you some details. So we are starting to implement that, basically.
Yeah.
And we started the design implementing it, basically. So we are, So I think it's good to get some feedback if that's aligned with what you guys are seeing or how you think about it. But to have that ability.
Yeah, we will do.
All right.
All right.
Thanks a lot for everybody attending. Thanks for you, Marcus, explaining. So I'll stop the recording and then we'll plan a follow-up next week. Okay.
Yep, great. Thanks, guys. Really appreciate it. It's really, really nice work.
Yeah. Thank you.
Cool.
Have a good evening.
Yep.
Catch you
Same.
next week. Thank
Cheers.
you.
Bye.
Bye.
Thanks. Bye.